So to begin with, we're going to just talk about some of the basics of math. And really, just so that you know, there are mathematicians out there, and they say that what math is it's the formalization of rules that we come up with when we notice patterns, really. So that's what we do, is we say, oh, there's a pattern, and then we come up with a rule for it. So going back to some really basics so you can see how that kind of works. Let's say that you had this many apples, right? These are apples right here I'm trying to draw for you. Let's see if I can see. Well, okay, you can make that maybe a little bit brighter and maybe try to get the focus a little better. I don't know. Okay, so you have this many apples, right? And then you went to the store and you got this many more apples. So now, one of the first things that we would do is naturally we would count them, and we would say, oh, you had this many, that's 1, 2, 3 apples. And then later on, we could count, oh, you're going to get 1, 2 more apples, and then we would realize, hey, your total that you have are 1, 2, 3, 4, 5. So your total is 5 apples, see? That's how many total you have. So in the beginnings of math, you learn about something called arithmetic, right? And in arithmetic, what we do is we learn that there are, first of all, these numbers here. These symbols are defined values, and they represent a quantity. So this number is defined as the quantity 3, the amount that you would get to if you counted using the natural counting numbers 1, 2, and 3. So it's 3 of something, right? And that's the same for 2, and that's the same for 5. But what we learn, because every time that you start with 3 and you add in 2 more, if you counted, you would get to 5. So we learn that you don't have to start this, once you put them together, you don't have to start counting the 3 over again, okay? And what we can do is just start with 3 and just go 4 and 5, count 2 more. So this is an operation called addition, right? That we're just starting with the 3 that we've already counted and just count 2 more, 1, 2, and then we can learn that a pattern developed that said 3, and if you add 2 more, that's going to make 5. So this is helpful for us, because if we have some big number that we don't want to count again, hey, I have 715 records in my collection, or CDs or something in my collection, and I just bought 1 more, that I don't have to start all the way from number 1 and count until I get to 716, right? Or with money, if the bank has $6,814,327 in the vault, and today they add another $50, they're not going to start with $1 to find out that they, where they're at. They just add the 50 on top. So arithmetic is very helpful. We know that we can use this operation because we see that it's always true. It always works, okay? Now, this right here is a way for us to understand what this quantity is together, okay? And so what we do is we say that when these 2 quantities are added together, then we get them equal to 5. So let's talk about what these are. These quantities right here are constants. Okay? They are defined and they are constants. And this thing right here, this is an operator. So it tells us an operation that we have to perform, which is to add these together, right? And then this thing right here, this is a comparative symbol. And they have a couple different names for this, but let's talk about what that is. It is a symbol that tells us to compare 2 sides here, right? It's the equal sign, and it says make a comparison. And if you ever notice, these are parallel lines that are drawn so that they're not bigger on one side or bigger on the other. The space between these lines is equal on both sides. So it's just telling us that this value here is exactly the same as this value here. And of course, these two are also constants, right? and this one is also a constant. They've been defined for us. So this is all that you really learn in arithmetic. We learn adding, we learn subtracting, multiplying, and dividing. Just a real quick example so that we can see the difference. When we add, it's 3 plus 2 equals 5. Add, take away 2, we would go 3 take away 2, and we'd realize that's 1. Multiplying. Multiplying is worth spending just a moment on here. Make sure that you guys have that right. In multiplying, we say 3 times 2, and of course in arithmetic we use an x, but later in math we learn to use this little dot, and that means multiply, 3 times 2. When I was a kid and learning about learning about math myself and learning about multiplication, my teacher made me say, instead of times, I had to say sets of. So I never was allowed in class to say 3 times 2. I had to say 3 sets of 2 every time. And that was actually a really good thing because it helped me understand that when I am doing this operation, I'm not showing the pattern I have 3 and I'm getting 2 more. I'm showing a different pattern. I have 3 sets of 2. So then that is this pattern, right? I have maybe 2 bags in each, or 2 apples in each of these bags, and I have 3 bags, so 3 sets of 2 each, and we know that that equals 6, and we could count them up and see. Okay, so that's the multiplication, and then division works the same way. If I took 6 and divided them into 3 bags, there would be 2 in each one. Or if I 6 and divide them into pairs of 2, it would take 3 bags. So multiplication and division are related to each other because they're both taking and organizing a quantity into sets of a smaller quantity, right? And they're comparing them. Addition and subtraction are related because they're taking a quantity and building more from that quantity or removing from that quantity, okay? So these are important to kind of know. These are the rules of arithmetic. And this is where it comes from, and this is why it's useful. But it's not the only useful math that exists. Let's talk about a situation where maybe you had some quantity, let's say some apples here, and you're going to add more apples. We'll say 2 more apples, right? And then you know you have a total of, let's say, 5 apples. So after the operation, we had 5 apples, right? And what we know is that we added in 2 apples. What we don't know is where did we start, but we know that they were added, right? So we can say, you know, this is what we know, that the total ended up 5, that 2 were added, and we don't know this where we started from. So problems like this, and this is the most basic kind of algebra problem. Okay, let's slide that over just a little bit. This is the most basic kind of algebra problem. We use symbols for this too. Of course, we use constants, right? And comparative symbols or comparative operators. And then we have, right here, another constant. And then we have an operation, right? And then or an operator, right? And then we have over here, to represent unknown amounts, well, that's when they usually use a symbol like X. Okay? That's the purpose. This is why we do algebra. That's one of the reasons, anyway. One of the big and early reasons that you learn is that we do algebra so that we can do what's called solving for the unknown. And so this is a variable. Called a variable, and we'll talk about why in a minute, but basically it represents an unknown amount. And then in pre-algebra you learn, hey man, I can solve for this unknown amount. Now you could do this, and you do algebra all the time in your head. When you said, hey man, I have 5 apples, she just gave me 2. I don't remember how many I used to have. I have to give her 2 back, but how many should I have when I'm done? Well, how do we do it? We just simply reverse the operation. We take away. In your head, you would say, oh, I have 5, but she gave me 2. Let me give her the 2 back, and I'll have 3. So that's really what algebra is. The steps of algebra are to reverse the operation. You know, you recognize the operation that 2 were added, and then you reverse it. So you would subtract 2, and then in an equation, in a story, if you're going to reverse 2 here, you're going to take away 2, you have to do that to the total as well. And then that way you can say, hey, before the story, right, all I had was x equals 3, right? So these are the rules that you learn. And the nice thing about rules is once you learn them, you can use them for much more complicated problems than these simple types of problems, right? You just follow those rules, and you know the rules always work, and that you're going to be okay. And you can deal with things that are much, much, much more complex, and that's part of the beauty of algebra. Now I'm going to tell you another quick story. This idea here is the idea that maybe we're going to make some, let's say we're going to make some cookies, okay? So Mr. T wants to make his famous chocolate chip cookies. So what does he put in those cookies? Believe me, you don't want these because I am not a baker that way to make nice cookies. We get them from somebody else. Ms. McManus makes very good cookies, by the way. So let's ask her for some later. Okay, so, but in my cookies I'm going to put flour and eggs and, let's say, I don't know, let's put in some sugar, and these can be chips, chocolate chips and sugar, and let's put in some, I don't know, maybe some baking soda or something, and some oil, maybe. I don't know if you put, probably not. Okay, but this is what goes into Mr. T's cookies. And then this is kind of a recipe. We're going to mix all this stuff together, and when we get done, we're going to have some score for how good it tastes. So now what happens is, of course, you taste my cookies and they're not very good, right? So what I'm going to do now is I'm going to change my amount of this I'm going to put in, right? I'm going to add extra sugar. So then I would have, some flours, some eggs, some chocolate chips. Then the sugar amount has changed, and then we have, this is the, what was it again? Baking soda, and this is my oil. And now we see that maybe I'm happier now because I've added some extra sugar and it tastes a little better to me. So algebra is very helpful for us to recognize that sometimes there are what we call relationships or relations between two different values. And if I change one, the other is impacted. And this is what we call, this relation right here is what we call a, could be what we call a function. Okay, so one of the things we learn in algebra, you guys spend in pre-algebra learning that over on one side of the axis you might graph a value, and we'll call this one my happiness value, and over here would be my sugar input value, right? How much sugar I'm putting in the recipe. And what we see is that it's not just that the sugar can be unknown, but it's that the sugar is also, and this is why we call it a variable, the sugar can change. I can change my recipe, and I can take a new amount of sugar, and the old amount was right here, and I wasn't very happy with it, and so I added some new amount, some changed amount of sugar, and I measured how did that impact my happiness, and said, hey, it was much better. So we have relations between things in the world. This happens all the time naturally. In the natural world, there is a relationship, a cause and effect sometimes, a correlation between two things, where we say, if this happens, that will happen. And if it happens to some greater degree, then we get some different outcome over here. So math, now algebra, becomes the tool for measuring the relationship between things. And this is why you spend time learning about ratios, and we spend time studying so much about slopes that you have already learned about. You spend so much time learning about slopes because we understand, man, the relationship between these two values has a slope that we can measure, and then that can help us make predictions. Well, what if I went even further with more sugar? Eventually, probably that's going to come back down, and then we get into some more complicated stuff. So I want you to just remember this. These are the two things I want you to remember from this lesson. Number one, or actually, I'm going to ask you this. Okay, there are two things that algebra is useful for, and here's what they are. Number one, they're useful for solving for unknown quantities, right? And these are the basics. There's more things as well. But the two basic things that we're going to have is, number one, solving for unknowns. So that's this story here. We have something, and then we had a change to it. We don't know what it is, and we want to find out what it is here. And number two, we're using algebra to make sure that we understand relations so we can analyze relationships. Okay? And that is in changing form. Okay, so we can analyze relationships. And those are the two key things that we're going to use algebra for.